So you guys have talked a lot about functions here and there, whether it was in Algebra 1, Geometry, this class. But we've got 3 different ways that we could characterize or describe functions. And in this case, we're going to describe them as either increasing, decreasing, or constant function. So we base those off of what the y values are doing as at the same time as what the x values are doing. So an increasing function is a function with a graph that increases as you move from left to right. So that's important to remember, guys, that it's always left to right. So a decreasing function is a function with a graph that decreases as you move from left to right. So the y values decrease as the x values increase. Increasing function, they both increase. If you have a constant function, then the graph is not going to increase or decrease as you move from left to right. And the y values do not change as the x values increase. So we're all talking, every single one of them is talking about the x values increasing. It's just based then upon what the y values are doing as the x values are increasing. So for our 3 examples, it says, state the domain intervals where each function either increases, decreases, or is constant. Now remember, domain intervals are left and right because it's your x values. So if we look at the first section, I don't worry about necessarily where it's increasing, decreasing, or constant. I just go from left to right. So from -5 to 2. So each time our x value is getting larger, we go by x values to the right. But it's not going up or down. So that section will be constant. So from -5 to +2, it's constant. The next section is from 2 to 3, and that is going to be decreasing. And the third section, it's increasing from 3 to +infinity. Now, quite honestly, I don't care if you use brackets or parentheses. The only one you can't use a bracket for is infinity. But the tricky part is, like, at the points 3 and 2, you can't really say, is it increasing or decreasing at that point. But that's the interval. So it really doesn't matter if you guys use parentheses or brackets. I wouldn't mark either of them incorrect. It's all a matter of preference. But infinity is always going to be parentheses. So go ahead and try number 2 and 3. So in example 4 says, sketch a graph for the situation described below, and it says to label your key information, that sort of thing. So it says the temperature in Fahrenheit during a snowstorm slowly decreased at the start of the storm. Then it reached the coldest halfway through the storm, and then quickly rose above the temperature at the start. And then decreased to the temperature at the start of the storm. So I'm going to go ahead and label my axes. So time is almost always going to be your x variable because that's your dependent or your independent, and then your dependent is the temperature in Fahrenheit. So the start of our storm, it says it slowly decreases to the coldest halfway through. So I'm going to mark on my time axis here about halfway through the storm. So if I just pick a random spot to start, it really doesn't matter. We have no specific values. I'm going to say it started here. So it's going to be gradual or somewhat not very steep slope. But quickly and slowly, that's what's describing your slope. So slowly decreased at the start and reached its coldest halfway. So remember, down here is your cold temperature, and up here is going to be your warm temperature. And then it says it quickly rose above the temperature of the start. So if the start is here, it's saying it quickly, so a steeper slope rose to be above where that start point was. So it should be a little bit steeper of a slope. And then it says it decreased then to the temperature at the start of the storm. So then we'll just draw. So if this is your start, that's where it then stopped or ended rising or falling. And that's it. So again, a general picture, but your slopes should, the steepness of your slopes should match the scenario. We don't have specific values, but there are certain things we can draw there.